Hello and welcome. In this video, we'll talk about solving polynomial inequalities. If you are watching this video, I hope that you've taken the time to look at solving linear and quadratic inequalities, which are basically polynomial inequalities of respectively first and second degree. Our focus for today will be polynomial inequalities of degree higher than 2. This lesson has been prepared for students who are taking the grade 12 Advanced Functions course MHF4U. So let's get started. The first example that I've selected is that of a third degree polynomial. We say it's third degree because the highest power of the variable x in this inequality is 3. Step 1. Take all the terms to one side of the inequality. Leave 0 in the other. In our case, I'm going to take all the terms to the left side. That's my preferred side when it comes to bringing or transferring the terms, and leave 0 in the other. And I'm going to write the steps as I go. All terms to one side, zero on the other. Next step, we want to factor the left side. And whenever we factor, we first look for a greatest common factor. So first, x is a common factor, as you notice, because every single term has a variable x, and then we have 2x squared minus x minus 6, bigger than 0. Yes, it is factored, but not completely. We need to factor completely. So we need to factor that quadratic over there. So the first terms will be 2x and x. Now we need to find the two numbers that multiply to negative 6. Remember, we need a sum of negative 1 for the middle. So negative 2, here we'll give negative 4x and 3. So see here, 2x times negative 2, negative 4x, plus 3x will give the negative x. So I think that we have factored completely here. And we'll write our step 2. Let me make it a perfect rectangle. Okay. So factor completely. Okay. So the next thing that we need to do here is find the zeros of each factor. So we have 1, 2, 3 factors. Now we want to study the sign of each factor, because what we are basically trying to do eventually is study the sign of the product. We want to know when this product is positive. And in order to find out when the product is positive, we will need to know when each factor will be either positive or negative. And we always start from finding the zeros, because the zeros separate the negative from the positive sign. So we're going to say that x equals 0, or 2x plus 3 equals 0, or x minus 2 equals 0. So the zeros are at 0, negative 3 over 2, and positive 2. So that was our step 3. We said that we are finding the zeros of each factor. Okay, so the next step is sort of a bigger step. We are going to solve this inequality by using a method that is called using a table of values, or using a chart. So we're going to build the chart, and this is how it goes. First, you draw a horizontal line, and then a vertical line. It's sort of a T-chart. So this part of the horizontal line will represent the number line with negative infinity going to the left and positive infinity here to the right. Now on the number line, we want to place the 3 zeros of this inequality. Remember that you have 3 zeros, and what you want to do is divide the number line into equal parts and place the zeros in order. So the number line, in other words, this one here, is not to scale. So what that means is we're going to start with negative 3 over 2, and here goes 0, and here goes number 2. Now the zeros have divided the number line into 4 intervals. So from negative infinity first, negative infinity to negative 3 over 2, and then negative 3 over 2, 0, and then 0, 2, and last but not least here, from 2 to infinity. Now, under this column, we're going to list all the factors of this polynomial. So the factors are x, 2x plus 3, and x minus 2. And we're going to draw the line here. And down at the bottom, we are going to write the product. So x, 2x plus 3, x minus 2. So the whole thing. What we are trying to do in this step is study the sign of each factor. So the sign of x, the sign of 2x plus 3, and the sign of x minus 2. And based on the signs of each factor, we will decide what sign would the whole product have. So let's get started with the first factor. So for the first factor, we're going to say x will be 0 at x equals 0. And for x equals 0, this factor will be 0, which makes the whole product equal to 0. So we'll say the whole product will also equal 0. Now we'll continue with the next factor, which is 2x plus 3. 2x plus 3 will be 0 at negative 3 over 2. So we're going to mark it by writing 0 in here because negative 3 over 2 is the 0 of 2x plus 3. Now, if 2x plus 3 is 0, then the whole product would equal 0, because if this is 0 times anything will equal 0. Last but not least, we have x minus 2. X minus 2 will be 0 at x equals 2. And if x minus 2 equals 0, then 0 times anything will equal 0. So that will make the product 0. Now, we're going to study the sign of each factor. So if x equals 0 at 0, then for values less than 0, it will be negative. So we're going to say negative, negative. Bigger than 0, positive, positive. And that's kind of easy decision to make. An easy decision to make because we just have x by itself, right? So if the number is negative, x will be negative. The number is positive, x will be positive. Now, when it comes to 2x plus 3, we're going to say that 2x plus 3 will be 0 at negative 3 over 2. And if you want to know what the sign of 2x plus 3 will be from negative infinity to negative 3 over 2, we need to either plug in a testing value, we call it a testing value, any number that you can get from this interval, from negative infinity to negative 3 over 2. So say, for example, x equals negative 10. If x equals negative 10, 2x plus 3 will change to 2 times negative 10 plus 3. So that will be negative. For x value bigger than negative 3 over 2, let's take a look at the next interval. Between negative 3 over 2 and 0, we can choose a testing value of negative 1. We're going to say that 2 times negative 1 plus 3 would be negative 2 plus 3, positive. Between 0 and 2, we can take a testing value of x equals 1. So 2 times 1 plus 3, 5, so that's positive. Between 2 and infinity, we can take a testing value, for example, of positive 10. Doesn't really matter. We can say that 2 times 10 plus 3, 20, plus 3, 13. So that's a positive. Now, the last factor is x minus 2. So x minus 2 is 0 at positive 2. Between negative infinity and negative 3 over 2, we chose negative 10. Negative 10 minus 2, negative 12. So that's negative. Between negative 3 over 2 and 0, we chose a testing value of negative 1. It's just a random number we pick from this interval, from this group of numbers. So negative 1 minus 2, still negative. From 0 to 2, we pick a testing value of 1, so which is a random number from 0 to 2. 1 minus 2, negative. From 2 to infinity, we pick a testing value of 10. 10 minus 2, 8. So that's positive. Notice that for all these factors, to the left of 0, they were negative. To the right of their zeros, they were positive. So if the 0 was at negative 3 over 2, to the left of it, negative. To the right, positive. The same thing here. To the left, negative. To the right, positive. Now, why does that happen? And this is in addition to, explaining how to solve the inequality. Now, remember that all these factors represent linear expressions. And if you were to graph them, for example, such as y equals x, or y equals 2x plus 3, or y equals x minus 2, they would all be represented by lines with positive slopes. Okay? So, and that's the reason why after their zeros, they would become, sorry, where are we here? I'm going to make this a little bit more clear. Let me just, here. So, for example, the first one, y equals x, will be a straight line, right? Here. 2x plus 3 would have a y-intercept at 3 and a slope of 2. It would be a line like this. X minus 2 will be a line with y-intercept at negative 2 and a slope of 1. So it would look like this. Okay? So beyond their zeros, right? This is the 0, this is the 0, this is the 0. So these functions, when exceeding their zeros, are positive y values. Now, to the left of their zeros, they are negatives. Okay? Okay, so what happens to the sign of the product? The whole thing. When we study the sign of the product, we simply multiply the signs of each factor. So we have negative times negative times negative will give a negative. Next, we have negative times positive times negative will give a positive. Next we have, positive times negative. That will give a negative. And last, positive times positive times positive will give a positive. Now the idea is we want the product to be positive. So when is the product positive? Positive products occur for the x values in this interval from -3/2 to 0. And we have a positive product from 2 to infinity. Therefore, we're going to say that the solution will be x from the intervals -3/2, -1, joined by +2 to infinity. Now, two things that I want to emphasize. This symbol here means united, so it's like a big U. It means join. So this is when we add two sets of numbers. So we don't use the sign plus or the symbol plus, but we use this symbol. Now another thing you need to keep in mind is the fact that here we want the product to be bigger than 0, which means the zeros won't be included, and you will indicate it by using round brackets instead of square brackets. And this is the end of the lesson for polynomial inequalities. So I am going to go over a few more polynomial inequalities as I bring more light to higher degree polynomial inequalities and the signs of the leading coefficients in the factors of a polynomial inequality. So I hope that this all made sense, and I hope that you continue practicing in order to really learn how to assimilate all this understanding. Okay.